Here's something that might surprise you. I recently analyzed job postings from 50 tech companies, and I found something fascinating. While everyone's debating whether AI will replace software engineers, these companies are actually increasing their requirements for skills that have nothing to do with writing code. They're looking for something completely different than what most people think. And if you're betting your entire career strategy on either learning AI or avoiding it, you're probably missing the actual game that's being played right now. I'm going to share what I've learned from working inside tech companies during this AI transformation, talking to hiring managers, and watching what actually separates people who thrive from people who struggle. Because the real story isn't about AI versus humans. It's about a fundamental shift in what makes someone valuable, and most people are preparing for completely the wrong thing. Let's start by clearing up the biggest misconception I see everywhere. When people ask whether AI will replace software engineers, they're asking the wrong question entirely. It's like asking in 1995 whether email would replace office workers. The question itself reveals a misunderstanding of how technology actually changes work. Every generation of workers has faced this fear. When spreadsheet software was invented, people genuinely believed accountants would become obsolete. Why would you need someone to crunch numbers when Excel could do it instantly? When computer-aided design software emerged, people thought architects and engineers would disappear. When search engines got good, people worried that researchers and librarians were finished. And you know what happened in every single case? The profession transformed, but the people who understood the domain deeply became more valuable, not less. Here's what actually happens when powerful tools emerge. The baseline expectations rise dramatically. Before spreadsheets, if you could create a budget with a calculator and ledger paper, you were valuable. After spreadsheets, everyone could create a basic budget, so the value shifted to people who could build financial models, perform scenario analysis, and translate numbers into strategic insights. The tool didn't replace the expert. It made expertise more important because now the expert could operate at a higher level. I'm watching this exact pattern play out with AI and software engineering right now. 6 months ago, if you could build a basic web application from scratch, that was impressive. Today, AI can generate that basic application in minutes. So does that mean developers are obsolete? Not even close. It means the bar has moved. Now the value is in people who can architect complex systems, make critical design decisions, debug subtle issues, optimize for scale, ensure security, maintain code quality across large teams, and understand the business context well enough to build the right thing in the first place. Think about it this way. AI has made it easier than ever to generate code, which means more code is being written than ever before. And you know what happens when there's more code in the world? You need more people who can evaluate that code, integrate it, maintain it, refactor it, and ensure it actually solves real problems instead of creating new ones. The bottleneck in software development has never been typing speed. It's always been decision-making, problem-solving, and judgment. Now here's where things get really interesting, and this is something I didn't fully understand until I started paying attention to how work actually flows inside tech companies. The assumption most people make is that AI is a replacement technology, but what I'm observing is that it's actually a collaboration amplifier. And there's a huge difference between those two things. When you work with AI tools intensively, what you discover pretty quickly is that it's not like flipping a switch where the AI takes over your job. It's more like having a very capable but sometimes confused intern who can work at superhuman speed but needs constant direction, feedback, and correction. You're not handing off your responsibilities. You're multiplying your ability to explore options, test approaches, and iterate on solutions. Let me paint you a picture of what this actually looks like in practice. Let's say I'm working on a new feature for an application. In the past, I might spend an hour writing the initial implementation, and that hour would be spent making dozens of micro decisions. Which approach should I use? How should I structure this? What edge cases do I need to handle? Now, with AI, I can describe what I want and get an initial implementation in 2 minutes instead of an hour. That sounds like I'm 50 times more efficient, right? But here's what actually happens with that saved time. I spend 15 minutes reviewing the AI's approach and realizing it made assumptions I didn't intend. I spend another 10 minutes refining my requirements and regenerating the code with better guidance. I spend 20 minutes testing the implementation and discovering edge cases the AI didn't consider. I spend 15 minutes refactoring the solution to match our team's architectural patterns. And I spend another 20 minutes documenting the decisions and trade-offs so the next person who touches this code understands the context. What used to take 1 hour now takes about an hour and 20 minutes, but the quality is significantly higher because I've been able to explore multiple approaches, consider more edge cases, and create better documentation. I'm not faster at completing individual tasks. I'm able to take on more complex tasks and deliver higher quality outcomes. That's the real transformation. And here's the critical insight that most people miss. The value isn't in the speed of code generation. The value is in the quality of the questions you ask, the judgment you apply when reviewing options, and the architectural decisions you make about which approach is actually right for your specific situation. Those skills don't come from learning how to prompt AI. They come from deep experience with software engineering itself. There's a specific point in every project where the dynamics completely change, and this is something I want you to really understand because it determines whether AI makes you more valuable or less valuable. I call it the complexity threshold, and it's the point where the system becomes too intricate to understand through surface-level interaction alone. When you're building something simple, like a basic calculator app or a personal website, you can actually work at the level of the finished product. You can click through the interface, test the features, and immediately see whether everything works correctly. At this level of complexity, AI can be remarkably effective at generating entire solutions. You describe what you want, the AI builds it, you test it, and you're done. This is what I'd call the vibe coding approach, where you're focused on the output rather than the implementation. But here's what happens as projects grow in complexity. First, the dependencies multiply. Your application isn't standalone anymore. It connects to databases, integrates with third-party services, relies on authentication systems, and coordinates with other parts of a larger platform. Testing your changes now requires getting all these pieces working together, which might mean setting up test data, configuring service accounts, or temporarily modifying other parts of the system just to exercise your new code. Second, the state space explodes. In a simple application, there might be 5 possible states the user can be in. In a complex application, there might be 5,000 possible states created by combinations of user permissions, subscription tiers, feature flags, geographic locations, device types, and interaction histories. You can't possibly click through all of those scenarios. You need to reason about the code itself to ensure it handles all these cases correctly. Third, the collaborative complexity increases. When you're the only person working on a project, you understand every change because you made it. When you have 5 engineers making changes simultaneously, you need systematic ways to understand what's changing, why it's changing, and how changes in different parts of the system interact with each other. You can't rely on testing alone. You need to read code, review architectural decisions, and maintain a mental model of the system. At this complexity threshold, something fascinating happens. Working at the level of the finished product actually becomes less efficient than working directly with the code. It's faster to read 100 lines of code and understand exactly what they do than to set up elaborate testing scenarios and click through countless combinations trying to verify behavior. The code becomes the product. Not the user interface, not the API responses, but the code itself. And this is where AI's role fundamentally shifts. Below the complexity threshold, AI can be a producer. Above the complexity threshold, AI becomes a thought partner and accelerator, but you need to be the architect, the reviewer, and the decision maker. You're not asking AI to solve the problem. You're using AI to explore solutions faster while you apply judgment about which solutions actually work for your specific context. Now I want to challenge an assumption that I hear constantly, especially from people who are excited about AI's potential. The assumption is that code is this obstacle we have to deal with, this arcane language that stands between us and getting things done. And once AI can handle that obstacle for us, we'll finally be free to focus on what really matters. But I'm going to argue that this gets things exactly backwards. Code is not an obstacle. Code is precision. And in complex systems, precision is the entire game. Let me explain what I mean by this. When you describe something in natural language, even very carefully, there's inherent ambiguity. Words have multiple meanings. Context matters. Interpretation varies. If I tell you to create a login system that's secure, you and I might have completely different ideas about what secure means. Does it require two-factor authentication? What password complexity rules apply? How long do sessions last? What happens with failed login attempts? When I write code or review code, there's no ambiguity. The code does exactly what it says it does. If I want to understand whether our login system locks accounts after failed attempts, I don't need to ask someone or search through documentation that might be outdated. I look at the code. Right there, I can see exactly what happens. 5 failed attempts within 10 minutes triggers a 30-minute lockout. Not approximately that. Not usually that. Exactly that. This precision has enormous value in several situations. First, when you're trying to understand complex behavior. AI can summarize code for you, but summaries always lose information. If I ask AI to explain what a function does, it might tell me it validates user input. But when I read the code, I see exactly which validations it performs, which error messages it returns, and which edge cases it handles. That precision matters when I'm debugging an issue or planning a change. Second, when you're ensuring quality. If AI generates code for me, I need to verify it meets all my requirements. A natural language summary from the AI about what it built isn't sufficient because the AI might have misunderstood my requirements or made assumptions I didn't intend. When I read the actual code, I can verify with certainty that every requirement is addressed. I can see that the code handles the edge case I mentioned. I can confirm that it follows our security patterns. I can check that it integrates correctly with our existing systems. Third, when you're making architectural decisions. Suppose I'm deciding between two approaches to solve a problem. If I rely on AI descriptions, I'm getting second-hand information filtered through the AI's interpretation. If I read the actual code for both approaches, I can evaluate the trade-offs directly. I can see that approach A is more flexible but has higher complexity. I can observe that approach B is simpler but less extensible. These nuances don't survive translation into natural language summaries. The irony is that as AI gets better at generating code, code literacy becomes more valuable, not less valuable. Because now instead of evaluating one approach that you painstakingly built yourself, you're evaluating 5 approaches that AI generated in minutes. Your ability to quickly read code, spot issues, assess quality, and make informed decisions becomes the bottleneck. The person who can't read code is overwhelmed with options they can't evaluate. The person who can read code has superpowers. So if we accept that AI isn't replacing software engineers but rather changing what makes them valuable, the natural question is, what should you actually focus on learning? And this is where I see people making critical mistakes in both directions. Some people say forget coding entirely, just learn to use AI. Other people say ignore AI and double down on traditional engineering skills. Both of these approaches miss the point. The most successful people I'm seeing in this transition are building what I call a layered skill stack. At the foundation, you have core engineering principles. This is your understanding of data structures, algorithms, system design, software architecture, security principles, and performance optimization. These concepts don't change when new tools emerge. A well-designed system architecture is valuable whether you're writing code by hand or generating it with AI. Understanding time complexity matters whether you're optimizing code you wrote or code AI produced. The second layer is technical implementation skills. This is your ability to actually read, write, and modify code in specific languages and frameworks. This is where a lot of people get confused because this layer does evolve rapidly. The JavaScript framework that's popular today might be replaced by something else in 3 years. But here's the key insight. The underlying principles remain constant. If you deeply understand how web applications work, you can pick up new frameworks quickly. If you only memorized the syntax of one framework without understanding the principles, you're stuck when things change. The third layer is tool proficiency. This includes your ability to use version control, debugging tools, testing frameworks, deployment systems, and yes, AI coding assistants. These tools make you more effective at implementing solutions, but they're useless without the foundation beneath them. This is the layer that changes most rapidly, and that's fine. You don't need to master every tool. You need to be good enough with current tools to be effective, and you need the learning ability to adopt new tools as they emerge. The fourth layer is domain knowledge. This is your understanding of the specific problem space you're working in. If you're building financial software, you need to understand financial concepts. If you're building healthcare applications, you need to understand healthcare workflows and regulations. If you're building e-commerce platforms, you need to understand retail operations and consumer behavior. This knowledge determines whether you build the right thing, which is far more important than building things efficiently. The fifth layer is collaboration and communication skills. This is your ability to work effectively with other engineers, translate between technical and non-technical stakeholders, document your decisions, review other people's work constructively, and mentor junior team members. These skills become more important as AI handles more of the routine implementation work because the human coordination becomes the primary challenge. Now here's why this layered model matters. When you have all 5 layers, AI amplifies your effectiveness across every single one. Your core engineering knowledge helps you evaluate AI-generated solutions. Your technical implementation skills help you modify and refactor AI code. Your tool proficiency helps you use AI effectively. Your domain knowledge helps you give AI the right context and requirements. And your collaboration skills help you coordinate with others in an AI-augmented workflow. But if you only have the AI tool proficiency layer without the foundation beneath it, you're in a precarious position. You can generate code, but you can't evaluate whether it's good code. You can build features, but you can't judge whether they're the right features. You can move fast, but you can't maintain quality. And when the AI tools change, which they will, you don't have transferable skills to fall back on. Let's talk about something that doesn't get nearly enough attention in these debates about AI and employment. The question isn't just whether AI can do certain tasks. The question is how market incentives shape what companies actually do with productivity improvements. Because history shows us that the answer isn't as simple as more productivity equals fewer workers. Think about what happens when a technology makes workers more productive. The standard assumption is that companies need fewer workers to produce the same output, so they lay people off. But that's only one possible response, and it's often not the one that companies choose. The alternative response is to keep the same number of workers and produce more output. Which path companies take depends entirely on market dynamics and growth opportunities. Tech companies operate in growth-oriented markets with massive room for expansion. Even the largest tech companies are serving only a fraction of their potential market. They're not in a steady-state maintenance mode where they just need to keep existing products running. They're constantly launching new products, entering new markets, and trying to capture more value. In this environment, productivity improvements create opportunity for expansion rather than redundancy. Consider what happened with cloud computing. When Amazon Web Services made it dramatically easier and cheaper to deploy applications, did tech companies reduce their engineering headcount? No, they increased it. Because suddenly projects that were previously too expensive or time-consuming became viable. Companies that could only afford to run 3 applications could now run 30. The productivity improvement didn't eliminate jobs. It expanded the scope of what was possible, which created more work. Or look at what happened with mobile devices. When smartphones created a massive new platform, did companies say we'll just shift our existing engineers to mobile and reduce headcount? No. They hired additional engineers to build mobile experiences while continuing to invest in their web platforms. The new capability expanded the market rather than cannibalizing existing work. I'm seeing the same dynamic with AI. Companies that can build and deploy software more efficiently aren't downsizing their engineering teams. They're expanding their product portfolios. Features that used to require 6-month projects can now be delivered in 2 months, so instead of doing 2 features per year, teams are doing 6 features per year. That doesn't mean they need 1/3 as many engineers. It means they can pursue 3 times as many opportunities with the same team size, and many companies are choosing to pursue even more opportunities by actually growing their teams. Now, I want to be completely honest about the employment situation because this is something people worry about for good reason. The job market has been challenging, and there have been significant layoffs at tech companies. But here's what's important to understand about those layoffs. They're not primarily driven by AI making engineers redundant. They're driven by companies overhiring during the pandemic boom and then correcting when growth rates normalized. If you actually look at the employment numbers, most major tech companies still employ significantly more people than they did 5 years ago, even after the layoffs. Google, Meta, Amazon, and Microsoft all have larger workforces now than they did in 2019, which was considered a strong employment market. The layoffs brought them down from pandemic-era peaks, but they didn't erase the growth that happened before the pandemic. And here's something that doesn't make headlines but should. Many of the same companies that did high-profile layoffs have been quietly rehiring in specific areas. They're not bringing back the same roles they eliminated, but they are growing headcount in strategic areas. The narrative that tech employment is in permanent decline doesn't match the actual data. What is changing is the bar for getting hired. When companies are adding roles, they can be more selective. They want people who bring multiple types of value. Someone who just knows how to code is less attractive than someone who knows how to code, can work effectively with AI tools, understands the business domain, and can collaborate effectively with cross-functional teams. The market isn't eliminating engineering roles. It's raising the requirements for what makes someone competitive for those roles. Given everything we've discussed, let's talk about how to actually position yourself for success in this evolving landscape. Because I think a lot of people are making strategic errors that will hurt them over the next 5 years, and I want to help you avoid those mistakes. The biggest error I see is binary thinking. People are treating this as an either-or choice. Either learn AI or learn coding. Either embrace the new tools or stick with traditional skills. Either bet on automation or bet on human expertise. This binary framing causes people to make unnecessarily risky bets. If you go all in on AI tools without building engineering fundamentals, you're vulnerable when the tools change or when you hit complexity that requires deeper understanding. If you ignore AI tools and refuse to adapt your workflow, you're artificially limiting your productivity and making yourself less competitive. The winning strategy is integrative. You build strong engineering fundamentals because those are the durable skills that transfer across tools and technologies. You develop genuine expertise in your domain because that's what allows you to build the right solutions, not just functioning code. You learn to use AI tools effectively because they're powerful multipliers of your existing capabilities. You cultivate collaboration skills because that's increasingly where the coordination challenges live. And you maintain learning agility because the specific tools and technologies will continue to evolve. Here's how this plays out practically. If you're earlier in your career, your priority should be building those engineering fundamentals. Take the time to really understand how systems work, not just how to use specific tools. Work on projects complex enough that you have to grapple with real trade-offs and design decisions. Get comfortable reading other people's code and understanding different approaches to solving problems. Use AI tools as learning accelerators, not as substitutes for understanding. Ask AI to explain concepts you don't understand. Use it to generate examples that help you see patterns. But don't let it do the thinking for you when you're still developing your judgment. If you're more established in your career, your priority should be expanding your strategic impact. Use AI to handle more of the implementation details so you can focus on architecture, mentorship, and cross-functional collaboration. Build expertise in the business domain so you can spot opportunities and frame problems effectively. Develop the judgment to know when to trust AI-generated solutions and when to dive deeper. And invest in the soft skills that AI can't replicate, like negotiating trade-offs between competing stakeholders or building trust with cross-functional partners. For everyone, regardless of career stage, there's a crucial mindset shift that needs to happen. Stop thinking about your value in terms of what you can produce in isolation. Start thinking about your value in terms of the problems you can solve and the judgment you can apply. The person who can write 500 lines of code per day isn't necessarily more valuable than the person who can write 100 lines of code per day if those 100 lines solve the right problem while the 500 lines solve the wrong problem. AI hasn't changed the fundamental reality that judgment and problem-solving are what create value. What AI has changed is that the execution part is getting easier and faster, which means the judgment part becomes proportionally more important. If you've been coasting on the ability to execute without developing strong judgment, that's a vulnerability you need to address. If you've been building genuine expertise and judgment, AI is making you more powerful, not more replaceable. Let me leave you with a perspective that I think reframes this entire discussion. The debate about whether AI will replace software engineers treats AI as the competition. But AI isn't your competition. Other people who know how to effectively combine human judgment with AI capabilities are your competition. And right now, there's a massive opportunity for people who recognize this and position themselves accordingly. Think about it this way. 5 years ago, the competitive question was, can you build software? If yes, you had value. If no, you didn't. Today, the competitive question is, can you build software faster and better by effectively using AI while maintaining quality and making good decisions? That's a more complex question with more dimensions. And it's those additional dimensions where you can create separation from other people competing for the same opportunities. The people who are going to struggle are those who resist learning either side of the equation. If you refuse to learn coding because you think AI will do it all, you're handicapping your ability to evaluate quality, make architectural decisions, and work at higher levels of complexity. If you refuse to learn AI tools because you think they're a fad or a threat, you're handicapping your productivity and making yourself more expensive for the same output compared to peers who have embraced these tools. The people who are going to thrive are those who recognize this as an in proposition, not an or proposition. Learn engineering deeply and learn to use AI effectively. Build technical skills and build domain expertise. Develop your individual capabilities and develop your collaboration skills. This isn't about hedging your bets. It's about recognizing that each of these dimensions makes the others more valuable. When you have strong engineering fundamentals, AI tools amplify your productivity. When you know how to use AI effectively, you can take on more complex engineering challenges. When you have both, you're not competing with people who only have one or the other. You're operating at a different level entirely. That's not job security in the sense of guaranteeing you'll never face challenges. That's competitive advantage in the sense of creating separation from other people in the market. I also want to acknowledge that this transition is genuinely unsettling. When the tools you use every day are evolving rapidly, when the job market is competitive, when you're hearing contradictory predictions about the future, it's natural to feel uncertain about the right path forward. That uncertainty is uncomfortable, but it's also a signal that you're paying attention to a real transition. The people who should be worried aren't the ones who feel uncertain. They're the ones who feel completely certain because they're probably not grappling with the actual complexity of what's changing. My advice is to treat this as a time for strategic investment in yourself. Don't panic and abandon skills that have served you well. Don't stubbornly cling to workflows that are becoming less effective. Instead, be intentional about broadening your capabilities in multiple dimensions. Take on projects that stretch your engineering skills. Experiment with AI tools to understand their strengths and limitations. Learn about the business domain you're working in so you can contribute strategically, not just technically. Build relationships with people who can teach you and who you can teach in return. The future belongs to people who can navigate complexity, apply judgment in ambiguous situations, collaborate effectively with both humans and AI, and continuously adapt as tools and contexts evolve. Those capabilities aren't about knowing the latest framework or the newest AI model. They're about building durable skills that make you valuable regardless of which specific tools are popular at any given moment. So yes, you need to learn how to code. And yes, you need to learn how to work effectively with AI. Not as alternatives, but as complementary capabilities that make each other more valuable. That's the real insight that most people are missing in this debate. The question isn't whether AI or humans will win. The question is how quickly you can position yourself as someone who knows how to create value at the intersection of human judgment and AI capability. Because that's where the most interesting work is happening, and that's where the greatest opportunities exist. Thanks for sticking with me through this deep dive. I know it's a lot to think about, but I believe getting this right matters enormously for anyone building a career in tech. If you found this valuable, let me know what resonated with you and what questions you still have. I'm always learning from these conversations, and I'd love to hear your perspective on how you're navigating this transition. Until next time, keep building, keep learning, and keep pushing yourself to grow in multiple dimensions at once. That's how you create real competitive advantage in a world where the tools are always changing.